Congratulations, you completed the Structural Design Patterns section. Here's a recap of all the topics we covered. We looked at all 7 structural design patterns from the Gang of 4 and identified the intent of each pattern. The adapter pattern changes the interface of an existing object to make it compatible with another object. The bridge pattern lets you combine 2 or more orthogonal class hierarchies. The composite pattern composes objects out of 1 or more child objects. The decorator pattern attaches additional functionality to an object dynamically. The facade pattern provides a high-level interface to a complex subsystem to make it easier to use. The flyweight pattern supports a very large number of fine-grained objects efficiently. And the proxy pattern provides a surrogate or placeholder for another object. We also talked about when to implement these patterns. Implement the adapter pattern if you need to use components from alternate or legacy platforms in your application. Implement the bridge pattern if you need to combine 2 orthogonal class hierarchies. Implement the composite pattern if you are applying operations to a tree data structure and the calling code doesn't care if the operations are applied to a composite or a leaf object. Implement the decorator pattern if you need to apply layers of enhancements to an object operation and you cannot use subclassing. Implement the facade pattern if you need to reduce the learning curve of a complex subsystem to make it more accessible. Implement the flyweight pattern if you want to reduce the number of object instances in a large data structure. And implement the proxy pattern if you need lazy object instantiation, you need access to a remote object, or you need to add access control code to an existing object. Okay, let's summarize these patterns one by one. So, the adapter pattern changes the interface of an existing object to make it compatible with another object. The pattern improves code reusability because it allows components from alternate or legacy platforms to be used in your application. The adapter pattern is part of a group of patterns for connecting objects together. It shares the group with the bridge, decorator, facade, and proxy patterns. Each pattern connects objects together in a different way. The bridge pattern lets you combine 2 or more orthogonal class hierarchies. This reduces the number of classes in your code and concentrates all implementation code in its own class hierarchy. This provides you with the freedom to make changes to both hierarchies without breaking the architecture, and you can even provide an implementation at runtime by using an abstract factory to create the implementation objects. The composite pattern lets you compose component objects out of 1 or more child objects. The pattern treats individual and composite objects in exactly the same way, and the pattern is ideal if you are applying operations to a tree data structure and the calling code doesn't care if the operations are applied to a composite or a leaf object. You can combine the pattern with an iterator or visitor pattern to provide enumeration support. Alternatively, some developers put the child management API in the component class. This also works, but it makes the pattern more brittle. The decorator pattern is a good choice when you want to attach additional functionality to an object dynamically, and you are unable to subclass the objects. The pattern applies layers of enhancements to an object operation. You can easily combine the composite and decorator patterns. This will create a tree structure of decorated components. The facade pattern provides a high-level interface to a complex, low-level subsystem. This makes the subsystem easier to use. You can either allow or deny clients access to the subsystem. Both choices have pros and cons, and there's also the risk of the pattern evolving into a common anti-pattern called a God object. Facades are often singletons, and sometimes you can use an abstract factory in place of a facade. The flyweight pattern allows you to support a very large number of fine-grained objects efficiently. But a requirement for the pattern is that the state information of each object can be retrieved quickly and on demand. The pattern reduces the number of flyweight object instances in memory by sharing them among clients. The flyweight pattern is often combined with the composite pattern to reduce the number of leaf object instances in memory. And finally, the proxy pattern. The proxy pattern provides a surrogate or placeholder for another object. You use proxies for lazy object loading, to provide access to remote objects, or to implement access control checks. You can combine the proxy pattern with the factory method pattern. This allows you to let a factory subclass decide what kind of real object to create. Okay, are you ready for the quiz? Let's get started and test your knowledge of structural design patterns.